Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is a business or database design concepts, and the same chapter, that is chapter number 21, that is the information retrieval. In the last class we have discussed, we have started, or we have done some topic, or some we can say the topics of this chapter, that is chapter number 21, that is the information retrieval. I'm going to continue this chapter in the today's session also, that is what is a crawling, how to search the information, how to retrieve the information from the web pages. But before this, let's take a quick review what we have covered in the last class, then moves to the today's topic. So let's start with the previous class session. In the last class we have started with we have covered with the topic that we have started with the topic, that is the relevance using the hyperlink. That is what is the hyperlink and what is the use of hyperlink, why we are using the hyperlink, and how one data will be linked to the another data, that is using the hyperlink. So early we have search engine ranked document by using the TF ITF method. So early method by using then rank the document by using the TF IDF based relative or relevance measures like those described in section 21.2. However, these techniques had some limitations when used on very large collection of documents, such as a set of the whole web pages. So whatever the web pages that is required, whatever the content that is required, so we need a database by which we can increase the data, by which we can enhance our data. That is a large collection of document, that is a set of all the web pages. In particular, many web pages have all the keyword that is used, that is more than one keyword that's satisfied in a typical search environment, that's satisfied in a typical user requirement, that is collection of the various web pages. And further, some of the pages have some users that want as answers often just a few occurrence of the query terms and would not get high TF IDF terms. So whatever the requirement, whatever the thing that is used, whatever the requirement that is used, that is required with the TF IDF score. However, researchers soon realized that web pages have many important documents, many important information that plain text documents do not have, namely hyperlink. These can be exploited to get better relevance ranking. In particular, the relevance ranking of a page is influenced greatly by the hyperlink. So whatever the hyperlink that is used, we are using the hyperlink on the basis of the on the target of getting the information, that is the information retrieval. The first point is popularity or popularity ranking. That is how the hyperlink will be generated. That is very popular, because if I'm seeking the information, I'm seeking the link for more than one time, that is getting the popularity, that is getting the priority among the users. So that link will become on the top, that is the popularity of the ranking. Then this notion of popularity is in fact circular, since the popularity of a page is defined by the popularity of the other pages also. And there is a page rank that is also introduced, that is also a measure for checking the popularity of the page based on the popularity of the pages that link to the page. Using the page rank popularity measure to rank the answers to query that give results to, so that much better than previously used ranking techniques, that Google becomes the most widely used search engine. So Google becomes the most widely used search engine that is used in a shorter period of time. PageRank can be understood intuitively using a random walk model. So whatever the walk model, whatever the rank model, whatever the walk model that is used in the page ranking systems. Not each and every page is used, not each and every concept is used, that is used in the page rank method. Page rank can be defined by a set of linear equations, that is defined with the linear equation that is given below. Now these are the other measures of popularity by which we can get our data, by which we can control our data. Then next is the search engine spamming. That is a practice of creating the web pages or set of web pages that is designed to get a high relevance rank for some queries. So whatever the queries, whatever the target, whatever the practices that is used to get the web pages, that is used to get the high relevance rank for the some queries, even though the sites are not actually proper popular sites. So even though the sites are not proper sites, not we can say the popular site, that is known as the search engine spamming. Then combining TF, IDF and IDF and the popularity ranking measures. So what is the combination, or why to combine the TF, IDF and the popularity ranking measures? Then we also discuss about the synonyms, homonyms and the ontologies. So synonyms means the same word have a same meaning. That is the same words, same meaning. That is a we can say that same words have a different meaning that is very similar to each other. That is a synonyms. In the same way, there is a homonyms, that is a single word have a different meaning, that is a homonyms, that is a single word with the multiple meanings. A better approach to the above problem is for the system to understand what concept each word in the document represents. So what is the main concept? Why to represent or what to represent the various concept in a document that is representing the various matters. A system that supports concept-based querying has to analyze each document to disambiguate each word in the document and to replace it with the concept that it represents. So whatever the concept, whatever the data that is required, that is using the concept-based querying, that is used to analyze the data, that is used to represent the table with the document that is used in the word-based concepts. Disambiguation based on nearby words is usually harder for such queries since queries contain many few words that is to use. So we are using the concept of the concept based querying that uses the concept of the picking the search system before the search continues. Then ontologies are the hierarchical structure that reflect the relationship between the concepts. Then we also discuss about the indexing of the documents, that is how to maintain the index of the document or what are the concept to use the or to maintain the indexing of the documents. So an effective index structure is important for efficient processing of queries in an information retrieval system. Document that contain a specified keyword can be located efficiently by using an inverted index that maps each keyword ki to a list si of the identifier that contains a ki function. If the popularity ranking is independent of the index term, that in case of the page rank, the listed SI can be sorted on the basis of the popularity ranking that is used. However, sorting on popularity score is not fully effective in avoiding the long inverted list scan since it ignores the contribution of the TF-IDF score. So every score that is available that is used in avoiding the long inverted list scan that is used to ignore the contribution of the TF-IDF scores. Then we also discuss how to measure the retrieval effectiveness, that is whether the information that is retrieved is effective information or not, that is a valid information, that is suitable, or that is important information that we get for getting the information, that is measuring the retrieval effectiveness. How effective the information we gather is how effective the information is. So each keyword may be contained in a large number of documents, and so compact representation is critical to keep space usage of the index low. So whatever the index, whatever the criteria that is used in the representing the method, that is used in representing the criteria by which we can use the space usage of the index low. Therefore, the set of the documents for a keyword are maintained in a complex form. So whatever the form that is used to maintain the data in the complex form, so that the storage space is saved and the index is sometimes stored, so the retrieval is approximate and the few relevant measures may not be. So whatever the measure, whatever the content that is used, that is not getting the content, that is not retrieve the content. A good index structure will not have any false draws but may permit a few false positives. The system can filter all the way around, that is for measuring the effectiveness of the information. Ranking strategies can result in false negative and the false positive, but in a more subtle manner. So whatever the data that is used, whatever the ranking technique that is used, that is represented in the false negative and the false positive. False negative may occur when documents are ranked as a result of the relevant documents receiving a low ranking. Then false positive occur when the irrelevant document get the higher ranking, but that information or that document does not contain the enough information, but otherwise they get the higher ranking than the relevant document, that is a false positive. Then a better and more intuitive alternative for measuring the precision is to measure it as a function of recall. So whatever the function, whatever the data that is used, so we can use the function for making the recall function that is using the precision, that is taking the care of the overall precision that is taking into the account. Another problem that is used with measuring the precision and recall lies in how to define that which documents are really relevant and which are not. So that is which are the documents that is very useful and which are the document that is not relevant to the content of the matter. The next is the crawling and the indexing the web. That is how to or when to crawl the index and how to index the web. That is the today's topic. So let's start with the today's topic. So the topic is crawling and indexing the web. That is how to make the crawling, how to we can say the locate the given information, how to index the information that is maintained on the web. That is the indexing the web. So web crawls are the programs. So these web crawls are nothing but the programs that locate and gather the information on the web. So whatever the information, whatever the criteria that is used to locate and gather the information on the web. They recursively follow hyperlinks present in the known document to find other documents. So whatever the information, whatever the hyperlink that is available, that is present in the known documents to find other document that is used in the web crawl program. Crawlers starts from an initial set of URL which may be created manually. So crawlers start from the initial set of URL, initial set of, we can say, initial data of the URL, that is a uniform resource locator, which may be created manually. Each of the pages identified by these URL are fetched from the web. So whatever the URL, whatever the pages that is identified by the URL are fetched from the web, fetched from the internet. The web crawls then locates all the URL links in these spaces and add them to the set of URLs to be crawled. So whatever the crawling part that is taking the URL link that have been fetched, and if they do not have already been fetched or added to the crawled set, this process is again repeated by fetching all the information that is crawled set. So whatever the program that is used to locate and link the data that is getting the information that is done by the crawling, that is done by the program that is known as the web crawl. By repeating the process, all the pages that are reachable by any sequence of links from the initial set of URL would be eventually fetched. So whatever the information that is in a sequence of the link that is available from the initial set of the URL, that is starting with the initial set of URL, that would be eventually fetched. Since the number of documents on the web is very large, so there are n number of documents that is available, that is very large, it is not possible to crawl the whole web in a shorter period of time. So in that cases, we are using multiple processes, multiple machines that is involving the crawling. A database stores a set of links or the sites to be crawled. It assigns a link from this set to the each crawl process, and new links found during a crawl are added to the database. So whatever the database, whatever the crawling that is used, that is a new crawl will be added to the database and may be crawled later if they are not crawled immediately. Pages have to be refreshed periodically to obtain the updated information and discard the sites that are no longer required. So pages are being refreshed and updated in an automatic way, so that the information will be updated or information will be gathered with the help of the crawling on a periodic basis to obtain the updated information, and to discard the site that is no longer exists, so that the information in the search index is kept reasonably up to date. So the information will be available in an up to date method. So there is also a dynamic generated pages, that is a spider trap, that is the prioritization or prioritization of the page fetches and ensuring that websites are not flooded by a burst of requests from a crawl. And pages fetched during a crawl are handed over to a prestige computation. So whatever the pages that is fetched during the crawl are handed over to a prestige computation and indexing system. And web crawl also depends on the relevant pages that is being reachable through the hyperlinks that is used. However, many websites containing large collection of data may not make all the data available in the hyperlink method. So whatever the hyperlink data, whatever the content that is used, that is not hyperlinked with each other, that is using the concepts of the web crawling. And the deep web crawl that extracts some such information by guessing what terms would make sense to enter. So it starts searching the content by making the assumption that is, yes, this terms is related to this terms, so that information will be passed. So this give the information by guessing what terms would make sense to enter, or what menu options to choose in such interfaces, or what are the various information that is available in the web search content. And the pages that is extracted by the deep web crawl may be indexed just like a regular web pages. So whatever the crawling, whatever the content that is used, that may be indexed with the web crawling, that is done by the web crawling engine. And the Google search engine, for example, includes the result from the deep web crawl, that is whatever the result, whatever the output that is found, that is available with the deep web crawl. Now next is the information retrieval, that is beyond ranking of the pages. So information retrieval, now there is a concept of the information retrieval that is beyond the ranking of the pages. We are not able to rank each and every page, but the data will be available before or while or without consent of the ranking. That is a beyond ranking of the page. So there is no concept of the ranking, but still the data will be available beyond the concept of the ranking. So information retrieval system were originally designed to find the textual document relating to the query. So whatever the query, whatever the data that is available that is related to the query, and later the extended to finding the pages on the web that are related to a query. People use search engine for many different tasks. So people use the search engine, for example Yahoo, Google, for different tasks, from simple tasks such as locating a website to the broader goal of finding the term that is of very good interest. Web search engines have become extremely good at the task of locating the websites that a user wants to visit. So whatever the website, whatever the link, whatever the URL that is used to get the higher facility, that is used to get the higher locating website that a user wants to visit. The task of providing information on a topic of interest is much harder, and we study some approaches in this section. So whatever the task, whatever the data that is available that is used to provide the information on a topic of the interest, that is much harder, and we study some approaches in this section, that is how to retrieve the information that is going beyond the ranking of the pages. There is also an increasing need of systems or for systems that try to understand document and answer the questions based on the understanding method. One approach is to create structured document from unstructured document. So one of the technique that is used to create the structured document, structured information from the unstructured document. What is the structured information? That is available in a sequence, that is available with the data that is used with the sequence, that is the structured information. And the information will be gathered by the unstructured information that will be used in the crawling of the index. So one approach is to create structured information from unstructured document and to answer the questions based on the structured information. So making the unstructured questions into the structured information. Another approach that applies natural language techniques to find the document relating to a questions and return the relevant segments of the document as an answer to the question. So whatever the answer, whatever the relevant segment that is used, whatever the content that is used, that is given the answers of the relevant questions. The next is diversity of query results. So whatever the diversity, whatever the query result that is diverse in the form by which we can enter the data, by which we can result the or input the data. Now today, search engine do not just return a ranked list of web pages relevant to a query. They also return the image and video that results relevant to the query. So whatever the video, whatever the content that is used, that is relevant to the query. So that is, if I'm getting something, if I'm seeking some information from the Google, then the image, then the video, everything is available with respect to the query. Further, there are a variety of sites that provide the dynamically changing content such as the sports, score, or the stock market triggers. To get the current information from such sites, user would have to first click on the query result. So first of all, user have to click on the query result. Instead of search engines, have created the gadgets. That is now search engine also create the gadgets which take the information from a particular domain, such as the sports, updates, stock prices or weather conditions, and format them in a nice graphical manner. That is representing the information in a nice graphical manner. That is also one of the main concern, one of the main diversity of the query result. Search engine have to rank the set of gadget available in the form of relevance in terms of relevance to a query and display the most relevant gadget that is used, that is using the best engine, that is along with the web pages, images, videos, and other types of result. Therefore, a query result have a diverse set of result types. So whatever the type of result, whatever the query that is used, that is getting the diverse result of the or set of the result type. Such terms are often ambiguous. So whatever the such term that is used, that is a ambiguous term that is used. For example, a query eclipse may be referring to a solar or lunar eclipse. So whatever the eclipse technique, whatever the query that is used, that is eclipse, that may be related to the solar eclipse or the lunar eclipse, whatever the development, whatever the related to the query, that is the integrated development environment known as the eclipse. Search engine attempts to provide a set of results that are diverse in terms of the topic. So the search engine provides a result that may be a lunar eclipse, that may be a solar eclipse, but it provides the information based on the keyword that is that we are going to interfere, that we are going to do the work, that we are going to minimize the work in the eclipse. Therefore, given a query that search engine attempts to provide results that are relevant to the most common senses in which query results are or query words are used. The results obtained from our web pages need to be summarized as a snippet. So whatever the snippet, whatever the content that is used, that is providing the concept of the snippet in a query result. Traditionally, Search engine provides a few words surrounding the query keywords as snippet that provides or that helps indicate what the page contains. So that helps the data that is what the page content, whatever the data that is available in the page content. For example, if a query or if a user queries about a restaurant, the search engine can generate a snippet that containing the restaurant rating, a phone number and link to the pages or link to the map in addition to providing the relevant link to the restaurant homepage. So whatever the home page, whatever the data, whatever the content that is used that is available with the restaurant home page. Then next is the information extraction, that is how to extract the information or what is the information extraction system that is used for extracting the systems. So information extraction system converts information from the textual form to a more structured form. That is converting the textual form, textual data form into the more structured form that is used in the information extraction system. For example, a real estate advertisement may describe attributes of a home in textual form. So whatever the real estate advertisement or real estate advertisement that is available that may describe the attributes of a home in the textual form, such as 2 bedroom, 3 bath house in the Queens, from which information extraction system given the attributes such as the number of bedrooms, number of bathrooms, coast and the neighborhoods. The original advertisement can be used with various terms such as the 2BR or the 2BR or 2 bed to denote 2 bedrooms. So whatever the bedroom that is available, that is used to structure the data in a standard way. An organization that maintains a database of company information may use an information extraction system to extract the information automatically from newspaper articles, information extracted with related to the changes. So this is an example that search engine designed for finding the scholarly research articles such as the Criticer and the Google Scholar crawl the web pages to retrieve the document. So we can retrieve the document, we can search the document on the basis of the information that we find that we provide with the keyword in the crawl engine in the Google any search engine that is used. And they use a linguistic technique, page structure and the user-defined rules for specific domains such as the real estate advertisement or the scholarly publications. However, on the web scale with millions of websites, the manual creation of such pattern is not feasible. So whatever the manual creation that is used, whatever the manual content that is used, that is not feasible with the content that is used with the logical concepts. Machine learning techniques which can learn such pattern given a set of training examples are widely used to automate the process of the information extraction. So whatever the information that is extracted with the help of the information retrieval. Information extraction usually have as error in some fraction of the extracted information. So whatever the extracted information, whatever the data that is available in the extracted form, that is available in the typically form that contains some information in the format that syntactically matched a pattern, but did not actually specify a value. Information extraction using simple patterns which separately match parts of the page, it's relatively error prone. So whatever the information that is used, whatever the information that is gathered, that is the information extraction that use the form that is using a simple pattern that separately matched parts of the page is relatively error prone. Machine language techniques can perform much more sophisticated analysis based on the interaction between the patterns. So whatever the pattern that is available, whatever the technique that is available that contains more sophisticated analysis. And the main target is to minimize the error in the information extracted and the minimize the amount of the information extracted. That is there will be a minimum error in the information that is extracted and the maximize the amount of information that is extracted. So minimize the error and maximize the information. Next is question answering, that is how to gather the question answering or what is the main technique of the question answering. So information retrieval system focus on finding the document that is relevant to a given query. So whatever the information, so the main target of information retrieval system that is to find the document that is relevant to the given query. However, the answer to a query may lie in just one part of the document. So answer to a query that is available in one part of the document or in some parts of the several document. Question answering system attempts to provide direct answers to the question that is posed by the user. So whatever the information, whatever the content that is used, that is posed by the user, that is a question answering system that is attempt to provide the direct access to the questions. For example, a question of the form that is who killed the Lincoln, that must be answered, or that may best be answered by the line that says Abraham Lincoln was shot by John Wilkes Booth in the 19 or 1865. This is the condition, or sorry, this is the answer that is used, that is the who killed the Lincoln. This is the question, and there will be a statement that is this person, or that Lincoln was shot by the John Cales in the 1865. But the system also inferred that who can be answered by a name and killed is related to the shot. Question answering system targeted at information on the web typically generate one or more keyword query from a submitted information. So whatever the submitted information, whatever the query that is used, whatever the data that is used, that is will be used to submit the query, that will be used to give the query on the keyword by using the keyword, that is what type of information is extracted. An issue in answering the question is that different documents may indicate different answer to a question. That is, for a single question, there will be a different answer, different document that contain different answers. These answers form a distribution of the values, and a question answering system that may choose the average, median, value of the distribution as the answer to be returned. So whatever the value, whatever the distribution that is used in the returning phase, that is used in the medium phase, that is used in the value of the distribution as the answer, to reflect the fact that the answer is not expected to be precise. Current generation question answering systems are limited in the past. Now next is querying structured data, that is how to access the, or how to gain the information from the query, that is the query access data, that is the query structured data. So structured queries are primarily used as a represented in either relational or the XML form. So whatever the structured data, whatever the structured query, that is represented in either the relational or the XML form. Several systems have been built to support the keyword querying on relation and the XML data. So whatever the several system that have been developed, there is a concept that is also XML language. That is 23rd chapter of this module. Now next topic is the directories and the categories. That is, what is the directory and how to divide the different directories, or how to divide the concept in a different directories or different categories. A typical library system may use a catalog to locate a book for which she is looking. So typical library will be maintained by using the catalog, or any library user may use a catalog to locate a book. Whatever the data will be available, that will be used to locate a book for which she is looking. When she retrieve the book from the shelf, however, she is likely to browse through other books that are located nearby. So whatever the data, whatever the content that is used, that is getting the results, that is getting the result that is located nearby. Libraries organize books in such a way that related books are kept close together. So whatever the library books that is used, that is kept together, that is organize some books in a way that related books are kept close together. Hence, a book that is physically near the desired book may be of interest as well. So whatever the book, whatever the data that is available, that is of the interest, that is near the desired book block, making it worthwhile for the users to browse through such books. So whatever the data, whatever the user that is used to browse through such book. To keep related books close together. So whenever I want that the related books are close together, for example, C++ book will be close together, C books will be close together with each other, that is, so that anyone can search the information, anyone can search the books in a very polite manner. That is, each topic have a book, for example, each module, that is a C++ database, has a module that is related with each other, that will be combined, that will be, we can say, that taken care of, that will be added, or that will be shelf, or that will be located on a shelf in a more precise manner, more close to it. Hence, a book that is physically near the desired book may be of interest as well, making it worthwhile for the users to browse through such books. So whatever the books that is available, that is used to search the information, that is used to browse such books. And to keep the related books close together, libraries use a classification hierarchy. So libraries use a hierarchy that is known as a classification hierarchy. Books on science are classified together. So whatever the books that is used, this is the example, that is the books on the science are classified together. That is the science books are classified, or we can say the set together. With this set of within this set of books, there is a final classification with computer science books organized together. In the same way, every book will be close together. That is a computer science book, mathematics books, that is organized together, and so on. Since there is a relation between the mathematics and the computer science, relevant set of books are stored close to each other. At another level, there is a classification hierarchy, that is the computer science books are broken down into sub areas. That is, they are broken down into sub area. That means dividing the, or we can say divide the computer science book into sub areas, into the mathematics area, into the development area. Because books are kept at only one place, each book in a library is classified into exactly one spot in the classification hierarchy. So library is classified, library is available in the classified into exactly one spot in the classification hierarchy. In an information retrieval system, there is no need to store related documents close together. So whatever the document that is used, so in an information retrieval system, whatever the retrieval system of the data, whatever the retrieval system of the information, that is the information retrieval system, that is, there is no need to store the related document close together. So there is no mandatory that in case of the retrieving the information in the easiest way, there is a relation, there is a relation, there is need to store the related information, related document close together. No, that is not the main requirement. However, such systems need to organize document locally so as to permit the browsing. Therefore, such a system could use a classification hierarchy similar to the one that libraries use. And when it displays a particular document, it can also display a brief description of the document that are close in the hierarchy. So whatever the hierarchy, whatever the content that is used, that will be classification of the various retrieval system that is used in the hierarchy. So this is the books. Then there is the science books, engineering books, and the fiction book. There is the science that is related to the mathematics, computer science. Computer science book is related to the algorithm, and there will be a graph algorithms. So as a result of the flexibility, not only can a document can be classified under two locations, but a sub-area in the classification can also result in a hierarchy. That is, multiple hierarchy will be maintained. That is, one book is related to another book is related to another book, and so on. Multiple books are related with each other. And therefore the classification hierarchy is now used as a DAG, that is a directed acyclic graph. That is a graph algorithm that may appear in a single location in the DAG but can be reached via multiple paths. There are multiple paths that is available, that is used to reach the information in a multiple path. Then what is a directory? That is simply a classification DAG structure. That is a classification DAG structure in which we can put the hierarchy, in which we can make the hierarchy. Each leaf of the directory stores links to the document on the topic represented by the leaf. So whatever the leaf that is available, that will be used to store the documents on the topic that is represented by the leaf. Internal nodes may also contain links, for example, to document that cannot be classified under any of the child nodes. So whatever the node, whatever the content that is used, that will be used to contain the links, for example, to document that cannot be classified under any of the child node that is available in the document methods. And to find the information on a topic, a user would start at the root of the directory and follow the path through the DAG until reaching a node representing the desired topic. So whatever the desired topic, whatever the content that is used, that is required in the various concepts of the database management system. Organizing the information in the web in a directory structure is a daunting task. What are the various problems to represent the information in a directory structure? Now the first problem is determining what exactly the directory hierarchy should be. That is, what type of hierarchy is, which is the root node, what are the leaf nodes, what are the parent child, what are the child nodes. So it's very ridiculous, or it is the main problem to determine what exactly the directory hierarchy should be. Then second problem is given a document, deciding which nodes of the directory are categorized relevant to the document. That is, which nodes are available, which nodes are divided into multiple parts or categorized relevant to the document. So to tackle the first problem, portals such as Yahoo have a team of internet librarians who come up with the classification hierarchy and continually refines it. So whatever the content, whatever the data that is used with the internet librarian, that is used with the classification hierarchy and continues the refining the problems. The second problem that can also be tackled manually by the librarian or website's maintainers may be responsible for deciding or where their sites should lie in the hierarchy. That is next problem, that is the main problem, or that main limitation is that there will be, or the maintainers may be responsible for deciding where their sites will be or should lie in the hierarchy. There are also techniques for deciding automatically in the location of the document, that is based on computing their similarity to document that have already been classified. So whatever the document, whatever the classification that is used, that is usually classified with the document that is used with the, generally the terms that is used for the computing the similarity to the documents. Wikipedia, the online encyclopedia or encyclopedia, addresses the classification problem in the reverse direction. Each page has a list of categories that is available to which it belongs. So this is the winding up of the chapter. So this chapter is also finished, that is chapter number 21. And this is a summary of this chapter, that is a summary. This says information retrieval system are used to store query textual data such as the document. So whenever we use a information retrieval system, that can be used to store and query the textual data. That can be used to store and query the textual data means whatever the textual data that is used, whatever the content that is used, that is representing the textual data in that is in terms of the query representation, that is in terms of the query formatations. They use a simpler data model that no database systems but provide more powerful querying capabilities within the restricted model. So whatever the restricted model, whatever the simpler data, whatever the data that is available that is used in the database systems, that provides more powerful querying capabilities within the restricted model. And then second point is queries attempt to locate documents that are of interest by specifying, for example, set of keywords. So queries attempt to locate a document that is of interest, that is whatever the document that is available, that is of interest for specifying, that is what are the various set of keywords that is used in the used to locate the documents. The query that a user has in mind usually cannot be stated precisely, hence information retrieval system order answers on the basis of the potential relevance. Then third point is relevance ranking makes use of several types of information. That is a relevance ranking may be used in several types of information that is used. That is a term frequency, that is how much term or how much each term is to each document. How important is the document? How important is the each term into the document? That is the term frequency. Then inverse document frequency, that is how inversely different frequencies are related with each other. That is a relevance ranking. Then popularity ranking, this is also one of the technique for finding the relevance ranking. Then similarity of the document, that is used to retrieve the information similar to the example document. The cosine metric is used to define similarity and is based on the vector space model. So whatever the model, whatever the space that is required, that is used to provide the, that is used to define the similarity among the various models. Then the page rank and the hub authority, that is also used, that is also defined in the various method that is used for the so similarity of the documents is also retrieved to get the information to that is similar to an example of the document. The cosine metric is used to define similarity and is based on the vector space model. Page rank and the hub authority rank are two ways to assign the prestige to the pages on the basis of the links to the page. So whatever the link, whatever the prestige that is available, that is used on the basis of the link to the page, that is linked with the page ranking method. The page rank measure can be understood intuitively using a random walk model. And another approach, another text information that is used to compute the popularity model that is used to score on the basis of the multiple factors such as the TF, IDF and the page rank to get an overall score for the page. So whatever the score, whatever the data that is available in the database management system. Now search engine spamming attempts to get an undeserved high ranking for a page. So whatever the search engine that is used to provide the attempt that is used to provide the high ranking for a page, that is a search engine spamming. Then synonyms and the homonyms complicate the task of information retrieval. Then we also studied in this chapter, that is what is the synonyms, what is the homonyms that complicate the task of information retrieval, that complicated the task, that is what is the information retrieval, how it is not used. Concept based querying aims at finding the data, finding the material that is used, that is finding the data for containing the specified concepts regardless of the exact words or languages in which the concept is specified. Ontologies are used to relate concepts using relationships such as is a or the part of. So whatever the concept that is used, whatever the data that is used that is related with each other, that is used to relate the concept that is used in the relationship. So ontologist provides a relationship, that is what type of relationship it is contained, that is a relationship or the part of relationship. Then inverted indices are used to answer the keyword query. So inverted indices are also used to provide the keyword query, that is whatever the keyword query that is used in the inverted indices. Then precision and recall are two measures of the effectiveness of an information retrieval system. So whatever the precision, whatever the recall that is used to provide the measures for effectiveness of an information retrieval system. Then we also talked about the web search engine crawl, that is used to find the web, to find the pages, analyze them to compute prestige measures and index them. Then techniques have been developed to extract the structured information from the textual data, to perform the keyword querying on structured data, and to give the direct answers to the simple question that is posted in the natural language. So whatever the natural language, whatever the data that is available, that is used to search the querying data on the structured data on the basis of direct answer that is given in the structured model. Then next is directory structures and the categories are used to classify documents with each other. So whatever the document, whatever the classification that is used, that is related with the each other, that is related with each other, that is the indirect answer to simple the questions that is posted in the natural language. Directory structure and categories are used to classify documents with other similar documents also. And these are the review terms of this chapter, that is the information retrieval system, keyword search. These are the various practice exercises, that is the relevance is given, structure is given, and finding the document that contains various n keywords. Then suggest how to implement the iterative technique for computing the rank, that is given the t matrix that cannot fit in the memory. Then suggest how a document containing the words, that is a leopard, can be indexed, such as it can be effectively retrieved by the query, such as using the more general concept, that is a carnivore and the mammals. Now suppose inverted lists are maintained in the blocks, which each block denoting the largest popularity rank, then the TF-IDF scores of documents in the remaining blocks in the lists. This is again the exercises question that is also used in this chapter. And this is a various question that is used in this chapter. And the main difference is, what is the difference between the false positive and the false drop? Now these are the various tools. This is the bibliographic notes that is used. Now part number 6 is also over, that is the data warehousing, data mining, and the information retrieval. That is how to store the data, how to mine the data, that is how to analyze the data, and how to retrieve the information, that is the information retrieval. Now next part is the speciality databases, that is what are the special databases that is used in the database management system, that is part number 7. And this part contain these we can say these chapter that is used in this part, that is the part number 7.